Hi, it's Ms. Young again, and I'm back with the second video in our series on conic sections. And today we want to make sure we are discussing parabolas, how to write the equations of parabolas, how to graph parabolas, and just understanding the different relationships that are related, that surround the points that are related to create the parabola. First, let's understand that a parabola is created when we intersect a double-napped cone by a plane, which is the picture you see here, and the plane intersects this double-napped cone in such a way that the plane really only cuts through one of the cones. And so as you see here, it only cuts through the bottom cone. And whenever that happens, we create a parabola. There's some information here that talks about the standard form of the equations for the parabolas, which we will see in just a few moments. But what I really want us to do is to focus on the actual parts that make up the parabola. So here in blue, we can see that the parabola has been graphed, and I can trace that pattern here. And I can see that the vertex of the parabola is here labeled as V, and the focus of the parabola is here labeled as F. Now, the distance from the vertex to the focus is labeled as P, and we'll have to do a bigger diagram of that later on in class. That distance P is the same as the distance from the vertex to this line, which is called D, which is the directrix. The line that you see here, A, is the axis of symmetry. The axis of symmetry and the directrix are perpendicular to each other, and that happens all the time. Even if you look over here to the right where the parabola opens horizontally, you can see that the axis of symmetry is a horizontal line and the directrix is a vertical line. So again, F is the focus, D is the directrix, V is the vertex. The distance from focus to directrix is equal to 2P. The distance from focus to vertex and the distance from directrix to vertex is equal to P. Also pay attention here to the sign of P. When P is positive, our parabola will either open upward, or if it's a horizontal parabola, it's going to open to the right. When P is negative, our parabola will open upside down vertically or to the left horizontally, depending on the orientation that we have. Now let's take a look at general form and standard form. General form for conics will not change. We have ax squared plus bx plus cy squared plus dx plus ef equals 0. That won't change at all. The difference here is that a will be 0, which means no x squared term, or c will be 0, which means no y squared term. So when you're looking in general form and you want to be able to identify a parabola, only x squared or y squared will be shown. If both x squared and y squared are shown, then you do not have a parabola. The value of b is always 0, again, as we are not rotating our conics. You can see here again in standard form that we have one version of the equation for a horizontal parabola and one form of the standard equation for a vertical parabola. So let's take a look at an example. You will need the handout from Blendspace or the one that I gave you today in class. So make sure that you have that handy. If you need to pause the video to grab that, feel free to do so. Now that you have your paper, you can follow along with me as I go through this example. We want to write the equation for and then graph the parabola that has a focus of 3, 1. It opens upward and it contains the point 5, 1, and we want to complete those steps below. I'm just going to make a really quick sketch over here of what we're after. We know that the focus is at 3, 1, and we know that this parabola opens upward. At this point, we don't know what the vertex is, and at this point we also don't know the equation of the directrix, which we'll talk about in a moment. But we do know that the focus is 3, 1 and that the parabola opens upward. So let's say, for example, it looks like that. If this is the vertex, then this distance from the focus I'll label as F to the vertex is known as P. And remember, the vertex has coordinates of H, K. The focus, we know, has coordinates of 3, 1. We were given that information. This is a 3. So what we want to be able to find is the vertex so that we can write the equation. They also gave us a point here that's on the line, which is 5, 1. So we're going to use that information to our advantage. First, the standard form that we need, because this parabola opens upward, is x minus h squared equals 4p times y minus k. And now what we will do is make substitutions for x and y. We were given those values. 5 is x, 1 is y. I also happen to know the value of h only because I know the coordinate for the focus, and the focus and the directrix and the vertex here all have the same x coordinate. So I know already that h is 3, but I don't know yet the value of k. So I'm going to make some substitutions here. X is 5, h is 3. We'll square that difference. I don't yet know the value of p, so I'll leave that as 4p. I can write y as 1, and then k I'm going to write as 1 minus p. Now you may be wondering, why in the world did Ms. Young just write k as the value 1 minus p? Well, remember that I know the focus has the point 3, 1. So the y coordinate of the focus is 1. I also know that the distance from the focus to the vertex is labeled as p. So if I can take the number 1, that's the y coordinate of the focus, and subtract the value of p, I'll have k, which is the y coordinate of the vertex. If that confuses you, not a problem. Remember that you can always go back and rewind the video, and it might be a point that you want to ask a question about tomorrow in class, and I'll make sure that I address that for you. Now I'm going to simplify this. 5 minus 3 is 2, so this is 2 squared. 4p doesn't change at all. But if I subtract 1 minus the quantity 1 minus p, 1 minus 1 is 0, and 1 minus negative p is just p. So I have a statement that says 4 equals 4p squared. And now I need to solve for p, so I can find out what that distance is. So if 4 equals 4p squared, then that means that p squared is 1 after dividing both sides by 4. And so the value of p is 1. Now, I like to stop here and make a point. Whenever I am solving a quadratic equation and I take the square root of both sides, which I've done here, I usually get plus or minus 1. But here's what happens. We were told that our parabola opens upward. And in order for that to be true, the value of p must be a positive number. And so for that reason, I'm going to make sure that I understand that p has to be greater than 0, and so I'll choose the value of positive 1 for p. And so now, since I know that, what I'm able to do now is to write the equation in standard form using h and k. H again is 3, and k is 1 minus p. So h is 3, k is 1 minus p, but I now know that p is 1, so 1 minus 1 is 0. So I can now write the equation as x minus 3 squared equals 4p times y minus 0. But y minus 0 is just y, and the value of p is 1. So this becomes x minus 3 squared equals 4y. So take a moment and let that sink in. Again, you might want to pause or rewind the video at this point to make sure you have all of the points down and you've written everything as needed. Next, we're going to graph the parabola created by this equation, and so we'll go through and talk about some of those features. Okay, now on to graphing the parabola that we just wrote the equation for. I have scaled my x-axis, and I'm going to go ahead and continue by scaling the y-axis. And you can take some time to do this as well. Remember, I always want to see your scale on your graphs. You want to make sure that you communicate exactly what your graph shows, and scaling the axes is one way to do that. Now we want to make sure that we give information about the parabola and label that information on the graph. First of all, we now know the vertex of the parabola. We know that it's located at 3, 0. So this is our vertex. I'll label it as V. I was given that the focus was 3, 1. So that's my focus. And remember that P is 1. That's the distance from the focus to the vertex. Now the distance from the vertex to the directrix is also 1. So that lets me know that below my parabola that there will be a line that crosses 1 unit below the vertex. And that line is known as the directrix. So the equation of the directrix, this directrix is a horizontal line. Horizontal lines always have y equals equations. And so the equation of my directrix is y equals -1, as -1 is where I cross here on the y-axis for this line. Next, I'm also told that the point 5, 1 is on this line, is on this parabola, excuse me. So 5, 1 is a point here that's actually on the parabola, and we're going to use that to our advantage as well. Keep in mind that the focus and vertex both pass through the line of symmetry, and that line of symmetry is perpendicular to the directrix. And so the axis of symmetry, I'll label it here as AOS, is the line x equals 3, and that's because I'm 3 units away on the x-axis. The axis of symmetry is important because it allows us to get other points that are on the parabola. For example, if I know that 5, 1 is on that parabola, from the vertex I've gone up 1 and over to the right 2. If I go back to the vertex and go up 1 and over to the left 2, then I have another point that's on my parabola, including the vertex as well as the other point that we were given as 5, 1. Now, you can get one other point on either side. One of those points we can get by just plugging in a value. For example, if I plug in 0 for x, I would have 0 minus 3 squared equals 4y. And so plugging in 0 would tell me that 9 equals 4y. So y equals 9 over 4, which is 2.25. So if I go to 0 and I go up 1, 2, and then just a little bit about there, that would be 2.25. So from the vertex, I've now gone left 1, 2, 3, and up 1, 2.25. If I go back to the vertex and go to the right, 1, 2, 3, and up 1, 2, a little bit about 0.25, then I have another point that's on my parabola. Then what you do is you draw that curve as smoothly as you can, going through the vertex and then the other 2 points that we've made, and the same on the opposite side, vertex and the other 2 points that we've made. Don't forget your arrows on the end, and that is the parabola that we have created based on the equation. Of course, I expect questions on this tomorrow, and we will go into a lot more detail, but this does give you an introduction. If you have any questions at all, please write them down and post them to Edmodo, and everyone else step in to make sure that you help and answer those questions. See you next time.